Hi, my name is Martin Hayes. I'm an engineering technologist here at Dell Technologies and part of the Global Engineering Outreach Specialist team. I'm here today to talk through VMware Cloud Foundation Day-2 NSX-T Edge deployment on demonstration on Dell EMC VxRail. So let's take a couple of moments just to recap on the written portion of this blog post. On the right-hand side, you will see the diagram from the blog post, which is representative of the logical physical design for NSX-T Edge in VCF. This will help us run through the workflow to help us deploy NSX-T Edge cluster integrated with Dell top-of-rack switch pair as a Day-2 activity. This will culminate in the deployment of a shared edge compute model for Cloud Foundation of VxRail in the management cluster, which is the default architecture. This will help us prepare for future software-defined use cases such as active-active and multi-region topologies and container-based use cases going forward. These will be reviewed in a little bit more detail in future blog posts. Finally, as ever, please refer to Dell EMC Best Practice Engineering Professional Service Guidance for implementation details. This is for demonstration purposes only. Okay, we're in SDDC Manager in workload domains and we're about to kick off the workflow. Here we're presented with an edge cluster prerequisite screen. Please take a moment to review these. These do highlight how important it is to understand in detail the underlying mechanics of the workflow. We click Begin, and we're presented with the Add Edge Cluster first page of the General tab of the workflow. We'll give our edge cluster a name. Note here there's a character limit of 20 characters, which I got wrong. We'll give an MTU, in this case 9000, an AS number, BGP AS number, in this instance 95010, which is our own NSX-T instance AS number. We'll give the tier 0 a name. We'll give the tier 1 a name. We'll run the default workflow as opposed to the custom workflow. Now the default, or the custom workflow rather, will give you a lot more options with regards to BGP, but in this instance, the default will be fine. And finally, we'll skip through quickly on the video the passwords for the edges, root, and so on. And we'll click Next. Finally, we'll do workflow management for the use case. This will introduce a large edge cluster, and we'll be running eBGP as a dynamic routing protocol. Next, we'll be presented with the edge node itself, configuration parameters. So we'll give it an FQDN. Of course, the prerequisite was here that they existed in DNS somewhere. We give our TEP IP address. In this instance, we'll give them a specific IP address for the two TEPs, TEP 1 and TEP 2, and the TEP gateway. Our edge TEP VLAN here, in this instance is 220, and the cluster. So the cluster, this is the edge VM will be deployed on, is the vSphere cluster. We'll give the uplink VLAN. So this instance, it's the uplink VLAN going to the top of rack left switch, which is VLAN 220. And the peer, the BGP peer on the top of rack switch on the left side, which is 220.1. We'll give the ASN peer number. So this is the AS number of the top of rack switch, which is 65001. And we'll give the BGP peer password. We'll give the second uplink, which is the link to the right-hand top of rack switch in the diagram. We'll give the peer address on the right-hand switch. And we'll also give the ASN peer number, which is 65001 as well. And finally, the BGP password. Now we need two edge nodes for active-active. So we'll run through this part of the workflow again. We'll give management edge-2-vcf.local. Its management interface address. Its management gateway. Its edge TEP. Its second edge TEP address. And its edge TEP VLAN, which is 212. And then the last edge was 212 as well, obviously, so my error there. Uplink VLAN, 220. The first uplink. So that's going to the left top of rack switch. Peer IP again, which is 192.2.220.1. And the AS peering number, which is 65001. Exactly the same as the first edge. Password again is the same as the first edge. Our second uplink, which is going to the right-hand top of rack switch. This instance VLAN 221. Its peer address on the top of rack with physical switch is 192.2.221.2. Or 1 rather. ASN peer number again, 65001. And we enter our BGP peer password. And we click next. So now we have two edge nodes ready to run in active-active. So let's just do a quick review here of what we've entered. So you can see here in the general tab, edge cluster name, the MTU, our local AS number, our tier 0 name, our tier 1 name, and our edge cluster profile type, which is default. Use case was for workload management. Edge form factor large, active-active, and we're running a dynamic routing protocol EBGP. Right? You can see here both edge clusters have a link to the left to top of rack A and a link to the right to top of rack right. Now we go through the validation tab. This checks that all the data has been inputted correctly. Now we won't wait. This can take some time. This can take maybe 5 to 10 minutes to complete. So we'll fast forward the video here. And we conclude the validation. So next, we'll take a quick look at the physical network layer, in particular the Dell top of rack switches that are running OS 10. Now, we won't go into the exact configuration of these switches because they can change from environment to environment. What we will do, however, is take a quick look at certain parameters to see if they exist. We'll look at the BGP neighbor relationships to see if they're established. We'll check to see if there's an injected route, and so on. These parameters are important, or otherwise the workflow will fail. So firstly, we're just running a few commands here to verify the presence of VLAN 221 on the right side switch and VLAN 220 on the left side switch. Secondly, we're taking a look at the actual running configuration for BGP, right? So this is very similar to what we have in NSX-T Manager within VCF. So we have a neighbor, we have a password, and we have a remote AS on both sides. So you can see the remote AS is obviously 65010 on both switches, which means they're eBGP neighbor peers of the NSX-T environment. Secondly, we run the show IPBG summary command, which shows that we're the state of our neighbors, right? So 220.2 and 220.3 on our left, and 221.2 and 221.3 on the right. We can see the remote AS, and we can see the state and the prefixes. So we're learning prefixes, and we're receiving and sending messages. So BGP looks good here. Next, the show IP BGP command. Again, a variation of, so we can see the the learned routes or the distributed routes on the right-hand switch. And note the difference here on the left-hand switch. We're actually advertising in the 0.0.0/0 or the default route to our neighbor with a next hop of 192.2.0.254, which is the northbound interface on this switch. Next, a key command here is show IP BGP neighbors. We call it the specific neighbor ID, 192.2.220.2. Note the presence of the key term established, right? So sometimes if BGP doesn't come up, it goes through a handshake process. So if it's open or active, that's not in a healthy state. So all neighbors need to be in an established state. And we'll see in VCF Manager or SDDC Manager or rather actually NSX-T Manager, that corresponding keyword in NSX-T Manager as well. So we see on the right switch, we see established as well on both neighbors. Finally, we'll do a show IP BGP neighbors advertise route command. So we can see on the right that we're actually advertising nothing to our peer in NSX-T. On the left switch, however, we're injecting the 0.0.0.0/0 or default route into BGP, and we're advertising it to our neighbor. This is important to note here because, as I said, unless NSX-T learns a route, it will fail the workflow. Finally, we'll take a quick look into the output of the workflow in terms of SDDC Manager, vCenter itself, and finally NSX-T Manager. This will highlight from the GUI the configuration output of the workflow itself. So firstly, we'll log into SDDC Manager itself and review the workflow. So we're in the workload domain here. And we'll just jump down to the status bar there in a second, or the taskbar, just to verify the completeness of the workflow. So you can see here it was successful. Next, we'll jump across into vCenter. And we can see here on the left that the 2 management edge virtual machines were deployed in that resource pool. You can see here they're running Ubuntu Linux. You can see here are four interfaces on those hosts. 3 being used, 1 for management and 2 for north, south, and TEP traffic. Same on the second edge. And finally into NSX-T Manager itself proper. So here we'll take a look at the fabric. Into nodes, and cross over to edge transport nodes. And we'll see our 2 edge transport nodes that are sitting in the vCenter repository. You see these are part of the edge cluster, management edge cluster as per the workflow. Next, we'll take a quick look at the profile, or the edge uplink profile. So this is where the underlying smarts happen in the diagram that's attached to this video. So you can see here the uplinks, uplink 1 and uplink 2 for the north-south traffic. Next, over to the networking tab. We go to Tier 1 gateways. Now there's a Tier 1 gateway that's been provisioned. It's been linked to the Tier 0, management Tier 0, but we haven't actually configured any AVNs or customer-facing networks just yet. We'll go into segments. These are the 2 segments for north-south traffic. One for VLAN 220 and the second for VLAN 221. Finally, a quick look at Tier 0, or the Tier 0 interface, or the Tier 0 rather. You can see our interfaces here, 4 interfaces across the 2 virtual machines. Remember that tier 0 lives across those 2 Ubuntu Linux virtual machines. We have an uplink on VLAN 220 from each and from VLAN 221 from each. Next, we click the routing tab. Now, there's not a whole lot to see here. Most of the information is in the BGP tab. So here you can see our local AS is 65010. We're running into our SR BGP routing as per the diagram. And we have 2 BGP neighbors. Top of rack left, or A, and top of rack right, or B. You can see here my neighbor address, 192.2.220.1 and 192.221.1. With 2 sessions initiated from 2 separate source addresses. And the status is successful. Now we'll click the info tab. And we see here our keyword again, as per the switch output, established. So it's not open, not active, but established. So established is a healthy state for that BGP relationship. We see a management edge 2. We see that's established as well to its peer. Note the remote port 179, which is the standard TCP port. Again, we go across to the other edge. We see this is established. And edge 2, also established. So we're in a good state here. Finally, the GUI it does provide a network overview or topology view, which can be quite helpful. So we can see here our tier 0, we'll just expand that a little bit. Our tier 0 with our 4 northbound interfaces, 192.2.220.2 and 220.3 and 221.2 and 221.3, northbound 4 links to our 2 top of rack switches. You can see the auto plumbing then to the management tier 1. And finally, a network overview.